Welcome, welcome. Week 11 of the Magnet Weekly CTF. We get the dance going on. With me, as always, we have Jessica Hyde, Tara Melton, and this week's special guest, Lynetta Hinch. How's everyone doing today?
Great.
Good.
Happy Monday.
Happy
Happy
Monday. Yes, yes, we are closing in on the end of the quarter-long CTF challenge. This week we have Lynn, and next week, Tara, we have you. And that's going to kind of wrap things up. So yeah, we're coming up to the bitter end. So make sure you're getting your points in. Make sure you're writing your blogs because I will say the leaderboard. There's a lot of people vying for that first spot, and I did just kind of wrap up the final challenge for the winner. So the winner gets something tacked on to their challenge. So I'm really excited about it actually. But right now, we are actually going to review Aaron Sparling's Week 9 challenge response. He kicked off Memory Month in December, and we're going to go ahead and start that off. And then we are going to cut back and kind of wrap up and issue out the Week 11 challenge with Lynn. So we'll go ahead and take a break, and we'll be right back.
All right. Hi, everybody. So we have pre-recorded Aaron's solve for week 9 of the first memory challenge. So Aaron, if you want to go ahead and share your screen, we can kick it off and look at your solve for all of the challenges.
So, are you able to see a Linux terminal?
Yes, yes, we are.
Perfect. Okay, and you're clearly able to hear me, obviously. So this solve is being done inside of a virtual machine. This is the most recent Remnix distro that's free to the community from Sans. So if you want to use it to solve this, you can, or you could have solved this using. So we're going to be using volatility, and you could have solved this, using the compiled executable, or you could roll your own on Linux or Windows or Mac and solved it that way. So inside this directory, you're going to see that we have our memory dump, which I'll highlight with my cursor right here. And so we're going to run volatility against this memdump.mem, and we know that the profile, because we're using volatility, this is actually 261, so we still have to provide it a profile, unlike volatility 3, which is still in beta, is a Win7 SP1 X64 underscore 23418 build number. And one of the first plugins that I typically run, and Jessica and I talked about this in our presentation, especially if we don't really know where you're going to start with, is the PS list. And the PS list, I think for most people, is pretty familiar because it looks a lot like, say, Task Explorer. But it can also be, I think for some, probably the most underwhelming and unfortunately one of the most undervalued. But it has a ton of information in it. And the reason why I run this plugin first is I want to see, well, what processes are actually running on the system. And if we look at this, we'll notice that there is a bunch of system processes, which is pretty normal. But what I'm looking for is I'm going to start looking for any user-related processes that, that would fall under Explore. And so as I start to look through this, I noticed I pinged instantly when I got this image on WinWord. And WinWord is one of, the very few user processes besides some Chrome and some Internet Explorer that's running. So there's not a whole lot of user-related processes that's running on the system during the time of the memory acquisition. So I thought, well, that's kind of interesting. I want to see the next thing I want to do is I wanted to see if there was any handles to file objects related to WinWord and try to recover any of those file objects. So the next thing that I did was I ran the handles plugin, and we ran it against that particular process. I'll stick to my script so that I don't get off script, which in this case is 3180, and that is the process ID, or the PID, the process ID for WinWord. And then I'm going to use the -T flag, which says, hey, I want to look at just file types. Right, so I don't want to look. I don't want to look at all the handles. I just want to look at file kernel objects that are related to this particular process. And so we're going to run this plugin, and we notice we get some output. And as we scroll through this output, I'm just generally looking for anything that might be of interest. And as we get down to the bottom third, we notice here that there is a .asd file for document 1, which is an autosave file that Microsoft Word will use to save the document. So we may be able to recover a backup or a ASD of that particular document, and then we can interrogate that potentially and see what's in it. So the next step, which I'm going to show you what I did. I pre-cooked some of this, but I created a dump files directory. So I want to figure out where this file is located. So I can do that by running the file scan command. So I'm going to run the file, or actually it's the file scan plugin. So this is a particular plugin. And I'm going to say I want to grep for this document1.asd. So again, for folks that might be new to using volatility, this is just invoking the volatility framework. The -f is saying read from this memory dump. We have to give it a profile. In this case, our memory capture is a Win7 Service Pack 1, 64-bit, and then the build number. And then this is the particular plugin that I'm asking volatility to run, which is the file scan plugin. And I'm going to pipe the output of that to grep. And I'm going to say, hey, just look for any signs of this document1.asd file. And when we do that, it's going to scan through these basically pool memory. And it's going to look for kernel file objects that, and then it's going to grep for anything that's related to what we're asking it for. And lo and behold, spoiler alert, it finds one hit. And so this is our offset to where this particular file resides in memory. So I'm going to copy that. And now I'm going to dump that particular, or we're going to attempt to dump that particular file. And I'm going to say, give it the name, the naming convention. And then the dash capital Q is the flag that this particular plugin, that the dump files plugin says, hey, you've got to provide it the offset. So this, again, this is the offset. And then we're going to give it a dash capital D for dumping it. And then we're going to say dump it to dump files. And this is going to run through, and it took this data section and it dumped it to our dump files document, or to our directory. So we'll cd into dump files. And there it is. And so now I'm like, well, hey, I want to take a look at what is in this particular file. So one thing that you can do is there's a tool on the Remnix distro called Flare Strings, which comes from the Flare group from Mandiant. And we could run Flare Strings against this data file, and we start to get some interesting strings. And if we look here, we see, maybe I should change my password too. And here is the answer to the first question. Wow underscore this underscore is underscore underscore uncrackable underscore password. So that would be the workflow that you could use to solve this particular question.
I love that you highlighted so many awesome volatility plugins in just that one challenge question. That's awesome.
Well, thank you. So having been able to solve the first question, we were able to locate a backup file for a Word document, dump that particular file, and then using strings, we were able to pull out what the user was looking to change their password to. So now question 2 asks, what is the MD5 hash of the file you recovered the password from? So we dumped it to dump files, and we can just use the MD5 sum that's built into Remnix and run it against that dump data. And this would be your answer or your solve to question number 2. So that would be your MD5 hash for question number 2. All right, so question number 3. What is the birth object ID for the file which contained the password? So we know that that file is that document1 document1.asd. So in order for us to find that, we need to extract the MFT record from memory. And if you're not aware, there is a plugin that will allow you to do that. And again, I have pre-cooked this, but I will walk through what the command is, but I won't run it just for the sake of time. But if we were to run this, it would look something like this. And then, so again, we're going to run the volatility framework, and we're going to run it against our memory capture. And we're going to run the MFT parser plugin. And I'm going to say --output equals text. So I'm going to write that as have it write it out as a text file. And you can dump the MFT to a directory, and I'll talk about that in just a second. So in this case, I had already created an MFT directory, and so the -D would point the dump to the MFT, and I'll talk about what that is in a minute. And then I need to create the actual output file of the exported MFT. So that would be --output equals, output-file equals, and then whatever you want to name it. And in my case, I named it mft.txt. So let me walk through what this does real quick. So again, we're calling volatility against our memory capture. We're saying run the MFT parser plugin. We're saying write the contents of that to a text file. And then on top of that, we could skip this step, but I tend to do it. With the -D, we're saying export or extract all MFT records that have resident data. So as you know, an MFT record is roughly 1024 in size. And so if the data is smaller than 1024, well, it's really smaller than about 600, it'll stay resident within the MFT. So it's possible that we could extract data from MFT records that's still resident. And then we're saying, hey, this is the file that we want you to name that. So if we were to run that, it would go through that whole process. But
I gotta say, Aaron, that is such a useful tip for people about that -D flag, because that a lot of times will just get you some great strings, some great content of resident files.
Oh, absolutely. Yeah, definitely. Like, it's been a huge win in some of my like IR type cases where I've been able to pull out, where I've not been able to find the actual malicious binary, but I've been able to pull out like configuration files or data files that are related to that particular file just from inside the MFT record. And in Jessica and mine's presentation, you can see you can get passwords sometimes from resident data in the MFT. So now going back to the question, though, we need to, it says, what is the birth object ID particular file? So we could grep, I'm just going to do case insensitive document1.asd, and we're going to say MFT, and it was called mft.txt. And so I'm just going to grep for any instances of document1.asd within that MFT record that we wrote to a text file. But I'm going to say, hey, I also want you to show me 10 lines above and 10 lines below anything that you hit on. So that's what the $C is. And so if we run this, we're going to see here is our MFT record for this particular file right here that we were grepping for. And then if you come down here, this would be your answer or your solve to question number 3. So that would be where you would find the birth object ID for this particular MFT record. So that's kind of cool.
Really cool.
That is awesome.
Really, yes. So recapping, we just ran the MFT parser plugin, had its data write it out to a text file, and then you could, I mean, if you're not comfortable with maybe using command line search techniques like using grep, you could just take that text file and load it into something like Notepad++, or in this case, Scite on the Remnix distro, and you could use the search feature inside those text viewer programs, and then you would be able to find it that way as well. So if we, I'd have to drop into that directory, but if we did that, we could just open it up in a text viewer and then use the search feature, and we would get the same output. So moving on to question number 5, or question number 4. oops, I got a little crazy there. What is the name of the user and their unique identifier, which you can attribute to the creation of the file this particular document to? So in order to answer this, we need to go back to the original process that we identified using PS list, and that was the WinWord process. So again, using volatility against our memdump, we're going to use the get SIDS plugin, and then we're going to say, hey, just show me the SIDS as they relate to process 3180. And this is going to go through and enumerate that for this particular. Oh, I'm going to have to give it its profile because I didn't export out my profile.
And again, if you're dealing with the volatility beta 3, you don't need to put in the profile in there.
Yes.
But not all plugins are yet available in the volatility beta 3.
Yeah, and one of the things that I typically do, and I probably should have done for this, is I'll export. If I know what my profile is, I will just export it out so that I don't have to keep typing it in. And it also keeps, like when you're doing longer commands or piping and to multiple other tools, it will keep your syntax down. But this particular plugin here, the Get SIDS plugin, and again, we're just interrogating the WinWord process, which is the 3180. We see that, yep, WinWord is in fact, and we find out that we have a user Warren, and here we get their unique identifier that includes their SID, their RID, and all of those good things. So in this particular instance, the solve for you would be, we just wanted the 1000 and the user's name Warren. So that's a really quick and easy way to start to attribute maybe particular processes to individual users on the box. All right. So question number 5. Question number 5 can be solved a couple different ways, and it can be a lot of fun, I think, to solve. So the question is, what is the version of software used to create the file which contained the password? Okay, so we can do this a couple different ways. So one of the ways that you can do this is actually what I'll do is I'll just up arrow, is we can, and that's a good trick for folks that are new to this too. If you just use the up arrow command, it brings up your last command that you entered into the command line, and therefore you don't have to keep typing it out all the time. You can just backspace over the plugin that you used. So in this case, I'm gonna start interrogating the registry. So just like I think a lot of folks have these sort of aha moments when they realize, well, wait a minute, I can pull MFT records from memory, and now they find out, like, wait, I can also get registries from memory. So yes, you can. So we're going to run the hive list command, and this is going to list all of the hives that are available to us in this memory dump. And the one that we're interested in is this one here. We're interested in the users into user.dat hive for Warren. And so we need this offset right here, the virtual offset, not the physical offset. We need the virtual offset to this hive as it resides in memory. And then what we're going to do is we're going to dump this particular registry hive. And so how we would do that is we would now use the dump directory plugin, and we give it dash lowercase o. Hopefully I did that. Yep. And then the virtual offset, and then the dash capital D, which is our dumping. And then I have created a directory called registry, and this will dump the into-user.dat hive into this predefined directory. So if we cd into registry, we can do an ll or ls or lsla, whichever command you want to use, to do a little bit of a sanity check. We actually see that, yes, there's data associated. So more likely than not, we have dumped the into-users.dat hive. So now you have it, and you can pull this into your tool of choice. So what I did is, you'll notice here I have an into-user.txt file, and I'm going to show you a couple different ways that you could solve this. So I used cafe from tzworks to parse the users into user.dathive and then generated a text file. And then I can just grep through that text file for information. So in this particular case, I'm going to grep with case insensitive for Office against the int user and see what I get. And in this case, I didn't get anything. That's interesting. Try that again. Grep -I Office. There we go.
Oh, you typed officer.
Oh yeah, I did. Of course I did.
Trying to figure out why it didn't work. Yeah.
There we go. It's always syntax matters. So check your spelling, kids. So here we will see a bunch of references to this. And so we could start to then granularly filter down. And this is one way that you could get to the answer, right? So going back to the question is, what is the version of software used to create the file containing the password? And we start to see references to Office 15 associated to the WinWord. So we know that the particular file, the ASD1 document, was associated to WinWord, and we see WinWord is now associated to Office 15. So we are starting to, build some sort of context around that, and we can start even diving down a little bit more into this particular registry hive if we wanted. So one of the other things that we can do is we can use the user assist plugin. So again, I'll up arrow, and we'll use the user assist plugin and make sure I spelled it right, which I didn't. User assist, and then we're going to use our trusty little grep again, case insensitive for Office, and we will get some output for this as well. There we go. So we start to see references for this as well, but you'll notice that with this there's no time and date value with it, and so it makes it a little tricky to maybe validate. So one of the ways that we can validate is by taking the user assist key and granularly digging into it by using the print key command. And so what I'm going to do here is, just for the sake of not fat keying everything. So, and I've got to give it the profile. And I will walk you guys through what this is doing. This print key plugin will allow us to actually target specific registry hives. So in this case, with the -K, I'm saying go after the software, Microsoft Windows current version run, explore the user assist key. And so when we do this, it'll show us the various subkeys that are associated with this particular key. And the one that we're, sometimes it can be trial and error, but I will tell you that this is the subkey that we're interested in. And so now we're going to take that subkey, and I'll back up and show you what I did here. So we took the subkey, we added the count, because I knew that there was a run count of 5, because we saw that earlier. And I might have been a little quick through that, but I'll go back to that. And then I took and I said, pump that output to less. And then what I can do is I can search through less. And one of the things that we noticed before when we were looking at the keys was there was some interesting values. If you pecked around in this, you would start to see a pattern. But one of the patterns that you would see is this pattern right here, which is kind of reminiscent to Office 15. So we do find this particular pattern, and in this pattern, we get some hex output. And here is that run count that I was talking about that we were interested in, these particular 4 bytes here, or that run count. And then the next section that we're interested in is these, I'll try to sweep these a little bit better. These 4 bytes here, and these 4 here. So we can take those values and using some Python scripting, we can pull out, we can decode this rot13, which would be the first step to kind of make sure that we're on the right path. And what that would look like is we would essentially say, hey, I'm going to copy this so I don't have to retype it every time, is we're going to clear my terminal. We're going to drop into Python 27, oops, it helps again to spell. We're going to use 27 by default. It drops into it by default, and so this is all written in 27. So here we're just defining this string, right? And then we're going to say, hey, we want you to now decode this as rot13. And we'll paste that in, and you can see here it's decoded the information that we got, and we're seeing the reference again to Office 15 winword.exe. So we were able to decode the rot13, but now we want to be able to kind of validate that. And so we can validate that, and I'll go back, clean up my screen a little bit. We will validate that by looking at the those hex values. Oh, I put it into less, sorry. So I'll bring it back. I'll quit out. This kind of happened really fast, so I'll talk about this again. So we ran volatility, we ran the print key command. Remember, I added that sub key. So here's the sub key. I added the count, and then I said pipe it out to less. And then when we did that, I used the search feature within less. So by hitting the / you can see it down here on the bottom, the blinking cursor. And I said, hey, search for this this string pattern that if you interrogated this a little bit, you'd see the string pattern that might represent the Microsoft Office 15. And then remember I said, here's our run count, but we're also interested in these 8 bytes here because this is going to start getting us our date and time. So we would copy that out, record that, and then we can use some Python to decode these values. So we'll quit out of this, clear our screen. We'll drop back into Python, and then a lot of this stuff you can find online. If you're not super familiar with Python, you can find a lot of these quick, easy little ways to convert dates and times with your data.
Or you could use CyberChef.
Or you could use CyberChef. Yes, you could.
Shout out to CyberChef
yes.
right there.
Yes, got to give a shout out to CyberChef. So the first thing we're going to do is we're going to do a little importing. So we're going to copy, and I'm just going to copy and paste in the script that I used. And then we're going to say the data is those hex values that I highlighted before. So that's we're assigning the value data to that particular hex string. Then the next thing that we want to do is we need to unpack that with, so we're going to unpack it with date and time. And when we do that, we get this value right here. And now we have to convert that value to get our date and time. So now we're going to import another Python library. And this is where the cutting and pasting will get a little tricky because it gets really, Python gets a little tricky or finicky with its indentation. So now we're defining a variable, which is convert window, win date. So we've defined our variable, and this is where you got to be careful when you cut and paste. So if you do have scripts that you find and you're cutting and pasting a little public service announcement, just know that indentation matters. So come back here, hit the tab key once, paste it in, hit enter, and we're just going to rinse and repeat for our little Python script that we have here. We're doing this conversion, and we have to indent again, otherwise it's going to be upset. And we're going to do this 2 more times. And I'll walk through what this stuff does. So we have one more to go. So we return out of that because we've defined all that. And now we're going to say, let's convert this value that we got up here when we unpacked these 8 bytes. We'll paste that in and we hit enter and we get our date and time. So here is a date and time in UTC that we can use then to go back and validate the user assist key that we pulled out to say, yes, not only is it showing the Office 15, but we can also then validate the date and time of that particular piece of evidence. Or
yeah, I love the way that you validated that with Python. Just super smooth, and you're staying on the command line. You don't have to leave where you're at.
Yeah, you don't have to jump to another tool, and you can just take the data that the tool is outputting. You can save that to just a quick little, like you can open up like a little text editor, or you can, you know, jump into, if you use like Vim or Nano from the command line, which there'll be a demo of that here in a minute. You could just drop in real quick, throw some notes in it, and save it so that you can pull those back in. So that was a couple different ways that you can solve that particular question. So we dumped the into user.dathive. We parsed it with a third-party tool. In this case, I used a commercial tool. I didn't use a free open source tool because I have access to it, and had that write it out to a text file. But there's plenty of, you know, you could use Redripper, or you could use Zimmerman's tools. There's a lot of registry tools out there that are freely available that you can use to parse that. We use the user assist plugin key from Volatility, but we noticed that it didn't have any sort of date and time stamps associated with it, so it kind of made validation a little tricky. And then we decided, hey, we're going to go a little bit more granular by using the print key plugin, and then finding what the sub key is, and then enumerating the sub key to get the data for that particular key that we were interested in, and grabbing the hex values and converting the date and time stamps. Well, first we decoded the ROT13 to make sure we were in the right process that we wanted to interrogate, which we were. And then we took the values from that hex output that we knew was associated with the date and time, and then used some quick little Python foo on the command line to convert that to the UTC timestamp, and boom. So that one is probably the most fun one, I think, of the group, because you can use a bunch of different plugins to get that solved, and there's a couple different ways that you can granularly dive in to get that data. So question number 6, what is the virtual memory address offset where the password string is located in the memory image? And so to get this solved, we're going to use another volatility plugin, shocker. So, and dash profile calls 17 SP1 8. Make sure I didn't fat finger anything. And so we're going to use, actually, I use this plugin actually quite often when I want to figure out particular strings, especially with like IP addresses, or maybe interesting files, like what processes they might be associated with. And so even though that's not what we're asking in this particular question, I will show you what I mean by that with the output, so that you can wrap your head around various different ways to use plugins. And I think that is probably the biggest, if you take anything away from this particular series of questions, is how you can utilize or leverage all the various plugins within the volatility framework to go after different targeted artifacts within memory, which is actually, I think, a lot of fun. So we're going to use the Yara scan plugin. So we're actually going to leverage Yara.
I love that. I don't think people know you can leverage Yara right in here.
Yes, we can leverage it in 2 ways. So we can leverage Yara by actually asking it to scan a Yara rule, or in this particular instance, I'm going to use the -U, which says, hey, I want you to take, and I'll show you what I mean here. I want you to take this particular string, which is the password, wow, this is an uncrackable password, and I want you to take this
Lie.
Yeah. So we're going to take this particular string, which is our password, and we're going to say treat this as a Yara rule in its simplest terms, and scan against the entire memory image and show me any processes that are, if it comes back with positives, it'll tell us what processes are associated with this particular string, if any. So imagine if this was, say, a document that you were interested in, if you're using doing like an insider investigation, or maybe particular image files that you might be interested in, or if you're doing incident response, maybe you run like NetScan against your memory image and you don't get any suspicious IPs pulled out, but maybe you find a malicious binary, and then when you dump its virtual memory address space and run strings against it, you find a bunch of IP addresses, but you don't know if there's any other processes that are associated with those IP addresses. You could put an IP address in here and it would run it against it, and you would potentially find what IP addresses that, or what processes might come back to that particular IP address. So because this is scanning, it can sometimes be a little slow. So it's scanning against the entire memory image. And again, the dash capital U is the condition to say we're not passing it an actual Yara rule, a .yar. We're saying, hey, take this literal string and scan. And so by doing this, you will see, again, we're on the right track, because going back to question number 1, when we ran the PS list, one of the only user processes that kind of stood out that wasn't like a browser was WinWord. And then we see inside of here is our password that's associated, and this is the start of the virtual address where this password resides in memory in the context of PID 3180. So, that was a lot. But running Yara scan against the string, which is your password, you would get this output, and this would be the answer right here. So again, what is the virtual memory address offset where the password string is located in the memory image? So this would be the start of where that is. I think we're on the last one. We are.
This is
right.
the last
so
one.
We're the last one. Okay. So and then again, this will show you what process that scan is associated with. So the last one is, now, what is the physical memory address where the what is the physical memory address offset where the password string is located in memory? So we use the Yara scan plugin against our memory image inside the volatility framework to find the virtual offset. Now we want to find the physical offset. And so in order to do that, we would want to, and I think I did it, great. We would want to write, and I'll show you what it looks like. You could write a quick little Yara rule. The way that you could do that is you could just use like the touch command. And in this case, I did touch password .yar, and I'm not going to do this because it's already done. I don't want to overwrite it. That would create an empty file. And then I went into sudo nano password .yar. And I'm going to go ahead and open this in Nano, because you'll see here is my Yara rule. And so the rule is password. The metadata is just you got to have your curly brackets to enclose your rule. For those of you that maybe have never played with Yara, it's kind of like strings on steroids. Meta is just a description, and this is just say find the password and dominate. And then all we're saying is we only have one rule, which is a string, and we're passing it this string, which is our password, and I'm saying ignore the case, and I want you to scan for both ASCII and Unicode, so wide strings and ASCII code. And then condition, it has to have a condition, just like that's your Boolean logic, and I'm saying any of those. So we can Control X to get out of that. So that would be a quick and easy way to write that. You could just, again, touch your file or however you want to create your file, and then if you want to use Nano or Vim, you can just open right up into it inside your terminal. You don't even have to leave the terminal or launch another application. Put the data in, save it, and you now have your password. So what's great is we can run Yara and Yara is baked into Remnix by default. And I'm going to show you, if you hit the dot or -H command, it'll give you a bunch of different flags and conditions for Yara. And what we're going to do is we are going to give it the -S. So I'm saying, hey, I want you to print all the matching strings, right? So we're going to say Yara, and then we're going to we're going to point it at our Yara file, and then we're going to say, so it's what I'm saying here is I want you to read from this Yara rule, and I want you to run that Yara rule against our memdump.mem, and then I want you to print out any readable strings. And again, because this is we're scanning against the entire memory image, it might take a hot minute, but it's not incredibly long. So here we go. And you'll see right here, we get a bunch of output, but we now have the physical offset in memory where the password resides.
Perfect. What an awesome challenge demonstration of really how to get down and dirty on the command line using Python and Yara strings and some raw Python to go ahead and do Route 13 decoding. Just fantastic walkthrough, fantastic challenge. I hope everybody's really enjoyed this series of memory questions. Thank you so much, Aaron.
Aaron, that was awesome. And what's really cool is how much data can be pulled just from a memory image. Like that blew my mind.
Oh yeah.
So it was awesome to go through all of those different questions and see how much of a story we could tell just by just the memory image, which is awesome. Thank you, Aaron. That was awesome.
I think that's the big aha moment for most folks is they don't realize, and some of that just comes from like, I don't think they realize like how much data is there. And then once you sort of understand how to bend some of these plugins to your will, you can, or approach them, as Jessica likes to say, differently. You can really go and target just specific things within memory and start to pull them out instead of dumping all the things, and then you're stuck with all this stuff that you have to sift through. So yeah, I think a lot of times people have these big aha moments where they're like, that makes perfect sense. Like, I'm so glad I can do that.
And what a story you just told just by those sets of questions. That's awesome.
Yeah. I mean, you can see how you can just granularly walk through just by, and again, it goes back to the first question, right? Like the first question, I think most people when they're learning volatility, the first plugin they always sort of run is PS list because it's warm and fuzzy and cozy because it reminds us of, Task Explorer, and we can wrap our head around programs running. But what I think people fail to realize is, as underwhelming as that plugin may seem, there is a ton of information that it provides the analyst.
The PID, right? Like even as you're going through 3180, 3180, 3180, the PID. Follow your process ID. That's what's going to help you get through memory.
Yep.
Follow the process ID.
Yes, and then just pivot off of all those little crumbs that you find, and just keep granularly digging down, and there you go.
That was awesome.
Well,
Thank you so much for that walkthrough, Aaron.
Everyone found this to be fun, and I hope it was somewhat challenging and not too, boring.
The goal is to learn, so
the
hopefully
goal is to learn. I hope
everybody
learned.
Yeah.
And even if people solve things another way, I don't think anyone else solved it exactly the way you did.
Well, no, that's you bring up a really good point. So like this is just one way to solve this or skin the cat, if you will. Like there are so many different ways. As Tara's cat probably runs. There's so many different ways that you could approach this problem and probably, and clearly get to the same answer. Like when we go back to I think it was question 5, when we have,
he invoked your cat.
Yeah,
I'm sorry.
The cat whispered. There's 3 different ways that we can approach that one question just by using 3 different plugins, which is great.
Love it.
Love it. Thanks so much, Aaron. Thank you so much for taking the time to be our guest challenge writer as well, and for walking through all that whole solution.
No, well, thanks for having me.
That's
awesome.
A
lot of fun. Yeah.
And we're back. Hope everyone enjoyed walking through Aaron Sparling's solves. He definitely, threw out the gauntlet with a bunch of memory questions, and I think everyone learned a lot from that. So really, thank you, Aaron, for contributing to the CTF. That was awesome. Yeah, definitely. I loved reading kind of through how you wrote out your questions and all. Yep.
Hey Trey, just last week, Aaron had a guest blog post, not related to memory, related to automation, but on the Magnet site if people need a little more Aaron in their life.
Awesome. Awesome.
We all do. Never enough.
Excellent. Well, this week, this leads us to week 11. So, Lynn, would you like to read? Actually, before we start the question, do you want to issue out your trivia question for the week?
Ooh.
Yes. In a recent interview, this DFIR Fit guru had a sign with someone wearing a Magnet t-shirt. What did the sign say?
Excellent trivia.
That's a good
I
one.
like it.
You got to use your brain for that one.
So first person to respond in the Discord gets the 5 points. So we'll be watching to see who gets that. So moving on now with week 11 challenge. Lynn, what's your week 11 challenge question?
The challenge question is, what is the IPv4 address that myaccount.google.com resolves to?
So there is your week 11 challenge. There might be a part 2 to that. We'll have to see. Stay tuned. Great. So Jess, who do you have on Cash Up this week?
So this week, tomorrow, we have the one and only Richard Davis of 13 Cubed. So that is going to be incredible. I love 13 Cubed.
Yep.
Absolutely incredible videos. I feel like it's December, like nominate Richard and 13 Cubed for Forensic Forecast Awards when it opens again, because just incredible content, regularly putting it out there, regularly breaks things down, you through some. Cannot wait to I feel like in the curtain. So I'm kind of excited about that tomorrow.
That's true.
Right?
Yeah.
Great.
That'll be a
look
good
forward
one.
Yeah, I can't wait to tune in on that one. And happy belated birthday to Lynn. Happy belated
birthday, Lynn. Did you have a good birthday weekend?
Thank you. I did lots of good food and good
Awesome.
friends. Yeah. Do I look older? The answer is no.
No.
No bonus points for that one.
I don't
Nobody
know.
should be answering
Maybe.
that on Discord.
I set myself up. My fault.
Great, great. All right. Well, with that, we're going to go ahead and we'll call it a week. And we will see y'all next week for Tara's question. Tara, are you throwing out the gauntlet? Like, where are you feeling for this next question?
We'll see. I'm looking forward to it. Hopefully everyone's really enjoying these memory questions because I'm having fun with them.
I would recommend everyone go to the website and look up Lynn and Tara's memory talks from MVS. They've done a bunch of them, so probably a good idea to kind of review those. I would be willing to bet. So
I can say that this week I'm really looking forward to reading all your write-ups on Jamie's questions, especially part 5. I hope that everybody learned some new investigative techniques there. So I'm just excited about that.
awesome. Great. Well, we'll see everyone next week for Tara's question. Have a good week. See ya.
Bye.
Bye, everybody.
Bye.
Good luck.